So good morning, everyone. Welcome back to Math 115. So today we're going to talk some more about the graphs of trigonometric functions, which is section 4.4. So I posted a homework for 4.3. I know, I'm sorry, I don't have all the homeworks posted because I'm doing them one by one because I'm creating them because the guy who I'm supposed to copy them from hasn't posted them. So sorry about not getting the 4.3 homework up until yesterday, but it's up now. And it's due on Friday at 11:59 p.m. Okay, so that's 4.3 homework. So that covers everything from 4.3, which was like what? Even and oddness, Pythagorean identities. Okay, angles bigger than 2 pi, reference angle, signs of the trigonometric functions, that sort of stuff will be on that homework. And your next quiz is going to be quiz 6 on Wednesday, November 9th. That's a week from today. So it'll be in this room, which is unusual. We don't usually have quizzes in this room, but we will have a quiz in this room next week. The content for that quiz will probably be something like 4.1 to 4.4. Probably 4.1 to 4.4. I might adjust that later, but that's what I'll say for now. My office hours are going to be tomorrow. I like having my office hours in the tutoring center. It's been nice in there. So we're going to keep going to the tutoring center as long as there's enough room for us to be in there. So tomorrow from 2:30 to 4, I'll be in the Math Learning Center. That's cont 102. Okay, any administrative questions before we start in on content for today? Okay, it doesn't seem like there are any administrative questions, so let's talk about what we talked about last time. So last time, was it 2 times ago that we did all the practice? It was 2 times ago that we did all the practice. Okay, so last time what did we talk about? We reviewed the Pythagorean identities, okay, which are easy to derive as long as you know, okay, go away please. As long as you know this one, okay, then you're going to be fine. So if you know sine squared plus cosine squared equals 1, you can just divide by cosine squared or divide by sine squared in order to get the other ones. So those are the Pythagorean identities. And then we talked about whether or not the trigonometric functions are even or odd. So we had this partner practice. And remember, even and oddness is really just to check, well, if I plug in a number into the function, I'm going to get a number out, right? And if that number is the same number that I get when I use the opposite input, then I call the function even, okay? So opposite input, same output, that means even. If we have opposite input and opposite output, okay, then that means the function is odd, okay? So why was sine an odd function? Sine was an odd function because the input is an angle, right? So the angle alpha could look like this, or whatever. It could look like this, right? Then what would negative alpha look like? It would look like down here, right? But the point is that if you put alpha and negative alpha, okay, in the unit circle, then they're going to point at 2 points on the unit circle, and there's going to be a relationship between those 2 points, namely that the x value will be the same, which is why cosine is even, and the y value will be opposite, which is why sine is odd. So we reverse the input. So we either do the input of alpha or we do the input of negative alpha. And what happens to the output of sine? Sine will give us the y value corresponding to the point, which corresponds to that angle. And since the y value, when we switch the angle, the y value becomes negative, we get that sine of alpha is y, but sine of negative alpha is negative y. So this is what it means for a function to be odd. So sine is an odd function, cosine is an even function, and tangent, as the quotient of an odd function and an even function, is also going to be odd. Okay, and the other ones follow simply from the fact that, okay, 1 over y versus 1 over minus y, right? If it's a reciprocal thing, reciprocal of an odd function is an odd function, reciprocal of an even function is an even function. So we also get odd, even, odd for cosecant, secant, and cotangent. So again, I want to impress upon everyone that what does the sine function do? Its input is an angle, and its output is the y value of the point on the unit circle, which corresponds to that angle. Okay, so we put the angle inside the unit circle. It points at a point. Okay, so we make a big dot where that point is, and that point has coordinates. Our job is to find the coordinates. Sine's job is to give us the y coordinate. Okay? All right. So that's that. And then we started well, okay. Let's stop here for a second. Are there any questions about, generally, how do we find sine, cosine, tangent, or any questions about why or how we see that they are odd, even, odd, etc.? Okay, it doesn't seem like there's any questions there. So after that, we moved on to a new topic. That new topic was, of course, the graphs of sine and cosine. So I like to put this animation on the screen because it does a great job of showing what is happening. How do we go from this unit circle thing to now we're going to have a graph? Okay, so here's how it works. Basically, we are going to do this process, okay? We are going to allow the x-axis here, okay? The x-axis is going to represent, where we are on the x-axis is going to represent the inscribed angle, okay? So if I'm at 5 pi over 4, what I'm supposed to do in order to get the height of the function when x is 5 pi over 4 is to put the angle 5 pi over 4 into the unit circle. So the angle 5 pi over 4 would be like a little bit more than pi, right? It would be down here. How can I see that? Because 4 pi over 4 would be pi, and I need to go pi over 4 more than that, which pi over 4 more than that is an additional 45 degrees. So that would look like down here. So what do I do to find the height of the function? I put the angle inside of the unit circle, and then I go to the point on the unit circle, and if I'm doing the graph of sine, which is what I'm doing here, then I look at the x and the y value, and whatever that y value is, that's what I choose to make the height of my function when the input is 5 pi over 4. Okay, so there's a correspondence here between this picture on the right is just a different representation of what we've already been talking about in the unit circle. Okay, so let's see that one more time for maybe a different angle. How would I get the height of the function? So how do I know how tall to make the graph? Well, I look at the input. The input here is pi over 2. What kind of angle is pi over 2? It's a 90-degree angle, or a right angle, so it would look like so. And then what? This angle points at a point on the unit circle. It's this point right here that it is pointing at. So I check, what is the coordinates of this point? The coordinates of this point are 0, 1, right? Since sine's job is to give us the y coordinate, I take that y coordinate, which is 1, and that's exactly how tall I make the graph, 1 unit tall. Okay? So you can imagine, basically, as I move from left to right in terms of inputs, what am I doing in the unit circle? What I'm doing is I'm inscribing larger and larger angles, okay? So if I go like 1, 2, 3, okay, what would these look like? They would look like 1, 2, 3, okay? So as we go to the right on this guy, what we're doing is something like this, okay? We're going like the hands of a clock, except we're going counterclockwise. This is what we're doing. Wow, it's kind of perfect how long this Apple Pencil is. It's perfect for being the hand of this clock. Okay, this is what we're doing. Okay, we're spinning around like that. And if we go all the way around, then we've gone all the way to, if we go all the way around, then we've gone all the way to 2 pi. Okay, that's what it would be like if we went all the way around, so on and so forth, and then we make it back to where we started, then we've gone 2 pi. And then what's gonna happen? Then, what is gonna happen if I plug in like the next value which would be something like, let's see if I can put it in here. So this would be what? This would be not 8 pi over 4, but 9 pi over 4, right? This would be 9 pi over 4, which what would that angle look like? 9 pi over 4 would be 2 pi plus an additional pi over 4, right? So 2 pi would get us all the way around, and then an additional pi over 4 will take us to here, right? So let me do this in pink. So 9 pi over 4, what would it look like? It would look like this, yes? And we would point right there, okay? So what is the height of the function going to be at 9 pi over 4? It's going to be the same as the height of the function that it was when we did pi over 4, because these two angles are coterminal. So sine is going to give us the same value. Sine of pi over 4 is going to be the same as sine of 9 pi over 4, which is what I get when I add 2 pi to pi over 4. What did we call those functions that they take the same value sometime later in this pattern, in this repeating pattern? Periodic, that's the word. So this is because sine is 2 pi periodic. So, and this is going to be equal to, what is it? It's like root 2 over 2 or something like that. So the way I'm going to make the height of the function here is it's going to be the same. Let me do something clever here. Okay, it's going to look like this. And what is the height of the function here going to be? It's just going to be whatever it was. I'm just going to, oh, that doesn't show up well. Let's do brown. Maybe brown will show. No, brown doesn't show up well either. Damn, okay. Well, watch this. We can do this kind of a picture. Okay, I didn't draw it exactly right, but let me fix it. Okay, so the height of the function, what are we going to do? We're going to take this picture, and we're going to copy and paste it, and it's going to go here. Okay, we're going to copy and paste it, so it's going to go there. And we're just going to connect the start to the end, and it's just going to repeat like this over and over and over and over again. Okay, so if you were to zoom way, way out, what would it look like? It would look like something like that. Yeah? Like an infinitely repeating wave. Okay, so this is how we get the graph of sine of x. Now let's see how we get the graph of cosine of x. Well, it's not going to be exactly the same. How is my procedure going to change when I want to graph cosine instead of sine? How's my procedure going to change? Yeah, Andrew? Yeah, exactly. Instead of making the height of the function whatever the y value of this point is, I'm going to choose to make the height of the function whatever the x value of the point is, okay? So that's a little bit more confusing because here we're trading a height for a height, right? But what are we going to do when we're doing cosine? We're not going to trade a height for a height. We're going to trade a width for a height, okay? So the height of the function will be whatever the x-coordinate is of the corresponding point. So 0 degree angle, it looks, so 0 degrees is, I know that the angle should be 0 degrees because the input is 0. So I put the angle 0 degrees, which just points straight to the right, and I look at the point on the unit circle. That point has coordinates 1, 0. Since I'm doing cosine, I take the x value 1, and what do? I make the height of the function 1. Then, sometime later on, let's see the next angle, pi over 6. When the input is pi over 6, I put the angle pi over 6 inside the unit circle, and I go to the point here. And this point has coordinates. The coordinates are square root 3 over 2, comma 1/2. So which one do I pick? I'm doing cosine, so I'm going to make the height of the function on the right, I'm going to make the height of it to be the x-coordinate of the point on the unit circle which the angle pi over 6 points at. Okay, so how do I know it's square root 3 over 2? Well, I just have that foresight because I've done this a lot, but what would you do? You would draw a vertical line and you would say, aha, this is a 30, 60, 90 triangle. The hypotenuse has length 1. I get the length of the short side by dividing that by 2, so that's 1/2, and then I get the length of the medium side by multiplying the short side by square root of 3, something like that, okay? So I take the x value and I make the x value to be the height of the function when the input is the angle which points at the point whose x value is that number. Okay, so it's just a different representation. So let's do another one. Well, next up is pi over 4, right? So let's show how we would do this one if we were without the foreknowledge. What would I do? I would put the angle pi over 4 in here. Then I would draw my triangle. I would make this a right angle because I know that's a right angle. And I know that this is 45, and I know that this is 45, right? Because pi over 4 is half of a 90-degree angle. So in degrees, it's 45. So this is a 45, 45, 90 triangle. I know that the hypotenuse has length 1, and my goal is to find out what are the coordinates of this point right here. So how would I do it? Well, I would go from the hypotenuse to the short side by doing what? What should I do to get the length of that side? Divide it by 2? We're close. Divide by square root of 2, right? So it's divide by the square root of 2. So it would be 1 over the square root of 2, which would be equal to the square root of 2 over 2. So this is going to be square root of 2 over 2. Oops, I put it in the wrong spot. This is square root of 2 over 2. How about, whoops. How about the other one? How about the other side? How do I get it? Yeah, it's going to be the same as this side because, what? They're across from angles which are congruent. Side lengths which are across from angles whose measurement are the same have the same length. So square root 2 over 2 is also this length. So what do you think I'm going to make the height of the function when the input is pi over 4? When the input is pi over 4, I'm going to take the x value and I'm going to make that to be the height of the function. Okay? All right. By the way, I updated the notes on Blackboard. I was really behind on that. But I posted all of this onto Blackboard. So if you want to see this, you can see it there and download the PDF. I'll try to keep it updated more frequently. Okay, so, and again, what is it going to be when I do 9 pi over 4? What I'm going to do is I'm not going to worry about it because I know that it should be the same as whatever the height was at 2 pi earlier. So what am I going to do? I'm just going to take this height here and I'm going to copy it over. So what am I going to do? I'm going to take this whole thing and I'm going to copy and paste it. So here's my point, and it'll look something like that, right? That's what it's going to look like. Okay, so to extend, I just keep going, keep going. Just keep this thing going by pasting the start onto the end. And it's going to connect perfectly because the function is, oops, not there, start and the end. It's going to connect perfectly because this function is 2 pi periodic. Okay, this function is 2 pi periodic. So again, we have the same relationship, which is that cosine of 9 pi over 4 is equal to cosine of pi over 4. Why is that true? It's true because cosine of t for any t is equal to cosine of t for any t plus any multiple of 2 pi. 2 pi n, where n is an integer. Any multiple of 2 pi. So I could also go to, what? Not just 9 pi over 4, but also 17 pi over 4. 17 pi over 4 will be the same height. And then 17 plus 8 would be 25 pi over 4. 25 pi over 4. Again, we're going to get the same height because we're just going to repaste this thing over and over again. Okay, and why is it true that it's going to be 2 pi periodic? Because 2 pi is what it takes inside for my angles to go all the way around. And then what's going to happen? I'm going to repeat that process. My hand is going to be in the same spot as it was, whether I go this far or whether I just went from here to here, right? 45 degrees, or if I were to do 405 degrees. It's the same hand position. So the height of this point, or the width of this point, will be the same as it was 2 pi units earlier. That's why the graph is going to repeat, because after you go 2 pi around, you're back where you started, and you're going to repeat all of the points along the unit circle. Once you go all the way around, you're back to where you started, and you're just going to do it over again, which is why when we get all the way to 2 pi, we're just going to do this whole process over again. Okay, we're just going to do that whole process over again. Okay, so do we have any questions on how we make the graphs of sine and cosine? Okay. Something you might notice, by the way, about these graphs is that they look kind of similar, don't they? They look kind of similar, except it's like if we took this whole thing and we just moved it to the left a little bit, right? If we moved it to the left so that this point here, like this point would go to here, yeah? If we moved everything to the left, we would get the graph of cosine, right? So they have that kind of similar structure. They're both like this nice smooth wave. It's just that cosine is going to start up here, okay? And sine is going to start right here and go up. And cosine starts at 1 and goes down. Okay. It makes complete sense because what is the point? Which is at 0 degrees. 0 degrees, the point's y value is 0. That's why sine is 0 here. The point's x value is 1. That's why cosine is 1. Okay, I say it makes complete sense, but I say that just with the hindsight of many years of math education. So, how do we feel about graphs of sine and cosine? Let's have some thumbs. Raise them high. Thumbs up if we feel good about it. Like I could make the graph. Like if I had to do the graph on a quiz, I could make the graph of this thing using the unit circle. And thumbs down if I feel like I would fail that quiz. Somewhere in the middle if you feel like you're in the middle. Okay, that's looking fairly good. Okay, well, I want to help you all to gain some more familiarity with this. So what I want to do now is something harder than this. So I'm going to give you a partner practice, which I think is a hard partner practice, but I think that it's something you can do, okay? And so here's what I'd like you to do. You know already what the graphs of sine and cosine look like. Right? So with this information, I'd like you to attempt to make the graph of the tangent function, which we know is going to be, tangent is just sine divided by cosine. So what am I going to do to get the height of the tangent function when the input is pi over 4? I'm going to take the height of sine and I'm going to divide it by the height of cosine, right? And so on and so forth. So maybe should I try to no. I'm just gonna show you here really quickly. Sine looks something like this. Okay, here's sine. And cosine, so this is sine. And cosine looks something like this, right? Cosine looks like this, cosine of t. Okay, so with this in mind, go ahead and work with a partner. See if you can get the graph of the tangent function. And spoiler alert, it's not going to look quite so nice. It's not going to look quite so nice, okay? Scroll back up to... no, I want to do this. I want you to use the unit circle to find out what the values are, because it'll be good extra practice for you, okay?
Yeah, I agree with you. Because personally, that's what draws my account. So then I think isn't it? One over two.
Or is there something sitting there actually?
I mean, honestly,
Oh, just went to the restroom.
we could probably just
Then
we could probably skip 5 or 6 and just do like bigger.
Then would you mind moving and working with Maya? Would that be okay?
Instead of doing like 5 or 6, 5 or 4.
Is that all right? Okay, thanks.
5 or 4. That's just 2. So like I'm like yeah, you're right. It would be y over x.
But for the cosine thing, oh no, just kidding, sorry.
It's like yeah, it's weird, but like get into these. I think we should
Yeah.
last I heard yeah. Exact signs of these were 2. Because you can just like multiply by the reciprocal. So then I read last night, I was like wait, exact oh wait, yeah. Wait.
You also can't get to that.
You're right. How did that work?
Like, it's like 2 over 2 times 2
I tried
over
to
2 equal 1.
It's not hard yet, but that's okay.
Yeah.
How's it going over here? Making it there. Have we run into any trouble yet?
You're on like a for pi over 2. Would it be undefined? Because it's y over x. You know, I said that before.
It's not really like 0,
It would be
like the angle
1 over 0.
So scary.
The angle basically turned all the way around, and then we're pointing again.
Okay, we're just gonna say that.
Right. So it's a bit of a difference, but in the end, we're pointing at the same place. We're pointing in the same direction. Okay, so let's start with 0. Right? Let's start with just 0. If we want to make 0, if we want to make the graph of tangent, we want to know what should the height of the tangent function be when the angle is 0.
It's square root 2, negative square root 2 over 2 over 2.
Right. 0 is right here. So what are the coordinates of this line? They're 1, 0. And the tangent function, you take the angle, you go to the point, what is the tangent function? You take the y value divided by the x value, the y value is 0, and the x value. So if I do 0 divided by 1, what do I get? So what's the height of the tangent function?
That would be 0 over.
It should be 0 divided by 1, which is 0. Yeah, you just continue that, right? How about pi over 4? Pi over 4 is the angle.
No, just kidding, it's
And what are the coordinates of this one? There's square root 2 over 2 and square root 2 over 2. If you take the y value and divide it by the x value, you get 1. So here's 1. This is going to be times the tangent of 0.
Yeah, right?
Yeah.
It's just is going to so it's just
Right here, we run into any trouble yet? Yeah, what's the trouble? Ooh, okay, that's tricky. So, what do we do when we do rational, rational? What do we do? Yeah, we do. Because you gotta think about what's happening as the angle, okay, as the angle gets closer and closer to here. Think about the limit. We have a fraction. The numerator is going to 1, and the denominator is going to 0 from above. Meaning it's going to be like, it's gonna be, you're gonna eventually get something like, if you're very, very close to here, what are you gonna get? You're gonna get something like,
He did say it's not going to
it's going to be
but
something
at least you did.
like 0.01 as an x coordinate, very close to the y-axis. And the y-coordinate would be something like 0.99. If you divide something like 0.99 divided by 0.0001, what number would you get?
No, he's fine.
Really big and
He was like,
what about
my brother's on
well, the numerator is again positive, but the denominator is going to be negative. So if we go, if you were to make it,
learning about.
what's going to happen? We're going to have the positive number divided by a really small negative number, which would give me a extremely large negative number, right? So what are we going to have?
I'm probably not.
So, I think we should go over the So, okay, let's think about this, right? So, what I want to think about is what's going on.
That's like so funny. I just
Okay, so.
At least we can drop
Which
it.
direction does the angle 0?
We can just drop it.
Nowhere, just to the right. Exactly. We don't do any angle at all. We just say, I don't turn at all. We are still facing to the right. So 0 degrees facing to the right. Or 0 right here.
Yeah, that was not.
And what are the coordinates at this point here? 1, 0. Now, if I want to grab the tangent direction, I want to ask myself, what is the output of the tangent function for a given input? I go to the point on the unit circle,
Just make it like
and I'm
tomorrow.
going to do
That's
something with the coordinates.
I called like
right?
one day and then
I'm gonna what?
next day. Well,
I'm gonna do 0 divided by 1. Y coordinate divided by the x coordinate. What do I get when I do 0 divided by 1? 0. So what's
I think
the
I'm
height
going
of the
home on
tangent
the
function? It should be 0. Okay, now let's do the next one. Pi over 4. Well, pi over 4 looks like this, and the coordinates at this point are, as you say, √2 over 2 and √2 over 2. So if I'm doing tangent, what am I supposed to do? I'm supposed to take the y coordinate, which is √2 over 2, and do what? Divide it by the x coordinate, which is also √2 over 2. What do I get when I divide it by so 1? So what's the height of the function? 1.
yeah,
Okay, yeah, so now we're in trouble, right? Because you can already see what's gonna happen.
Oh, when we're doing that?
We're gonna be divided
Well,
by 0,
it's,
right?
it's a negative.
That's a no good thing. So what did we do when we had rational functions, right? When we had division by 0, what showed up in the graph?
So it would be like.
Not a whole, but a.
Oh, okay, because then you go back to 0.
A whole is when we had 0 divided by 0. But if we have something like 1 divided by 0, what's gonna happen? I don't know. So what's happening? Because what's helpful, anytime we have an asymptote, is to ask ourselves, well, what's happening as we get closer and closer and closer to that? Right? We know we're gonna have some kind of asymptote. We need to figure out, is this like an up-down, or is it a down-up, or is it an up-up? Right? And how we do that? We investigate what is happening as we get closer and closer. Which, as the angle input gets closer and closer to pi over 2, you can think of this hand as marching steadily closer and closer to 2, but I do know this is pointing straight up. And what happens when it's very, very close to pointing straight up? What do we have? The y value will be very close to 1, and the x value will be very close to 0 and plus. Importantly, it should be positive, very close to 0 and positive. So if I take a number like 0.99, right, and I divide it by something like 0.0001, right? If I take a positive number and divide it by an extremely small positive number, what kind of number will I get? I will get a really large and positive number. Positive, positive, takes positive. So what's happening? As we get close here,
Yeah.
we're going up to it.
You don't like it?
Now let's think about the other side, right? Think about if my angle were to march slowly from here and get closer and closer in the other direction. Then what am I doing? It's as if I'm taking my hand and I'm marching it in this direction. Yes? If I march the hand in this direction, then what's happening? The y value will be positive, close to 1, and the x value is going to be what? Really, really small and negative. What happens if I take a positive number, divide by something really, really small and negative? You're going to get a negative number, and it should be really, really big, because we're dividing by a really small number, right? So, what kind of behavior are we going to see on the left side? Well, it's going to be going to negative. Does that make sense? So we got some kind of situation like this happening. Yeah. Does that make sense?
Right, I need to check.
Okay, so again, so we're not talking about describe like what is the height of your function at this point. And we know that it's undefined, so we're gonna do one of these. And then what we're gonna say is, well, I know there's this height, and then this height, and then this height is this whole thing. A little bit you also here, something more like this. We're gonna get really, really close to this. When we get really, really close in terms of angle, that means the hand is getting really, really close to here, which means that the numerator is getting, of our fraction, is gonna get close to 1, and the denominator is gonna get close to 0 from above, which means this is gonna blow up. And on the other side, what I'm gonna do is, well, I don't know exactly what it's doing. I know it's going to be the same one. I'm gonna connect that with whatever I have. So it's 3 times. I'm going over here. Yeah, it's weird, right? So what's the problem? The problem is we're dividing by 0, right? But we were able to make graphs of functions just divided by 0 when we did rational. Remember that? What would happen if the denominator became 0 in the rational function? Yeah, we had an asymptote, right? So, same deal here. What's happening if we march our angle closer and closer to pi over 2, right? That's what I want to understand. What happens to the value of the function
I know.
when
It makes my slider
the
really
input becomes
really
very close to pi
Like,
over
it's like
2?
40 minutes.
What's happening like
Just one.
at this kind of an angle,
I'm like, why
right?
does time here go so fast?
Remember, to get the height of the tangent, so we're going to take the y value and divide it by the x value. So what is the y value? Very close to 1. Very close to 1. Almost the size of 1. How about the x value? It's getting closer and closer to 0 from above. So we get something like almost 1 divided by 0.0001. What kind of number will I get when I do that? A really large and positive number. So what is going to happen as we get close to pi over 2? We're going to have an answer just like that. Okay, now let me ask you, what would happen if I were to instead approach pi over 2, not from the left, but from the right? Okay, so I'm going to mark my x value in this direction. I'm going to ask myself what happens if I
Wait, where is
We're going to corresponding, basically trying to take our angle closer and closer to pi over 2.
So expensive, then
So if we're to do that,
It's on the swim team.
then what do we get? We get an angle like this, right? Where, again, the numerator is really close to 1. The denominator, what's it going to be? Really close to 0, but negative. But I think most people were able to figure out that something really bad is going to happen, right? What's the bad thing that's going to happen? We're going to divide by 0, right? But that's not a problem. Well, it is a problem, but it's a problem we can deal with, right? Okay, because we already know what we should do when we divide by 0. What we check is, what do we do close to the left and close to the right? So, what is happening? Well, let's do the graph of tangent now. I'm going to take the height of the white curve. No, I'm going to take the height of the yellow curve, and I'm going to divide it by the height of the white curve. When the height of the yellow curve is 0 and divide by 1, the height of the tangent function will be 0. At pi over 4, this is where the heights are the same, right? It's root 2 over 2, root 2 over 2, right? So when the heights are the same, the height of the function should be root 2 over 2 divided by root 2 over 2, which would be just 1, right? So here's 1. Okay, and then what's going to happen? As we get closer and closer to pi over 2, okay, what's happening is the y value is getting closer and closer to 1, and the x value is getting closer and closer to 0, but in a positive way. So if we take, for example, an input which is very close to pi over 2, but less than pi over 2, we will get something like 1 divided by some really, really small number. But importantly, this really small number is positive. Positive divided by positive is a positive, and a regular number divided by a really small one will, all things held equal, be really large. So what's happening as we march our angle closer and closer to pi over 2 is that the value is going to positive infinity, okay, positive infinity. And on the right side, what's happening? Well, the only difference is that now this denominator becomes negative, right? Because the x value is very close to 0, but importantly, it is close to 0 and negative. So this is going to cause the ratio to flip from being positive to being negative. So what's going to happen? Again, we're going to come like this. 3 pi over 4 will be here. And then at pi will be here. And then as we go up to 3 pi over 2, we're going to get another asymptote. Okay, and then finally something like this. Okay? All right, thanks for your attention. Have a good day. We'll go through that again at the start of class tomorrow.
Have a good day.
Yeah, you too.